Bismillahirrahmanirrahim. Assalamu alaikum students. Today we will be learning about split plot design. Now, what is the situation or in which situation we use split plot design? Split plot design is utilized or employed in a situation when one factor requires larger experimental units as compared to the other factors, or the factors that we are using requires different sizes of experimental units. Daily life example can be, suppose we have an experimental material and that is the field, and we want to test two factors, factor A and factor B. Suppose factor A is different types of machinery that are used for plowing. We want to test the different levels, and the factor B is different levels of fertilizer. So factor A is basically representing machinery and factor B is representing fertilizer. So factor A, which is machinery, cannot be applied to smaller area or smaller units. For machinery we require larger area or larger plots to be operated. Similarly, for factor B, which is the fertilizer, we require smaller area or smaller units. So what we will be doing, we will divide the whole experimental material into whole plots or bigger units, and those bigger units will be called whole plots, and different types of machineries or different level of the machinery will be randomly assigned to those bigger areas or whole plots. Now we will divide each whole plot into smaller units which are called subplots. If factor B has 3 levels, then each whole plot will be divided into 3 parts. If it has 4 levels, then each whole plot will be divided into 4 parts, and vice versa. As you can see from this arrangement that the whole plots, they are distant from each other. That's why there will be larger differences between among their results, and due to that larger differences there will be a bigger experimental error or a large experimental error. Similarly, the subplots, they are near to each other or they are very close to each other. That's why the experimental error will be smaller. So another reason to use split plot design is that whenever we require more precise results about one factor as compared to the other, then we use split plot design, and the factor about which we required or about which we want precise or accurate result will be assigned to subplots, because subplot error will be smaller. Now, for analysis, when we will be constructing ANOVA, we will require two different types of errors. Why? Because the units are of different sizes and their experimental error are different. Like for whole plots we will be having larger experimental error, and for subplots we will be having a smaller experimental error. That's why we will require to calculate two different types of experimental error. In ANOVA, in this source column, first we will write the whole plot source, then its error, then the subplots or the split plot source, and then interaction, and after that in the last we will write the split plot error. We will calculate and write the sum of squares in the next column, and after that we will be writing the degrees of freedom column. After that mean square will be calculated, and for F column, the column in which F statistic will be calculated, we will divide the mean square of the whole plot source. We will divide that mean square by the whole plot error. Similarly, the mean square of subplots and the mean square of the interaction will be divided by the split plot error. So on the whole we will be having three values of f: one for the min or whole plots, second will be for the split plot, and the third will be for the interaction effect. So in conclusion section, first we will be testing about, or we will be concluding about the interaction. Basically the hypothesis for interaction effect is written as there is no interaction between the two factors. This is the null hypothesis, versus there is interaction between the two factors. If the calculated value of f for interaction effect turns out to be non-significant, then we will conclude that there is no interaction between the two factors. Or if the calculated value of f for interaction effect turns out to be significant, significant means if the calculated value of f for interaction effect is greater than the table value of f, then we will reject H naught. H naught is the hypothesis of no interaction effect. If we reject that, then we will conclude that there is interaction, or there is significant interaction between the two factors. If the interaction effect is significant, then main plot and subplots have little meaning. You can go for its conclusion. Like we will be testing we will be checking the calculated value of f for the whole plot with the table value, and if that turns out to be significant, then we will say that there is significant differences among the whole plot factor levels of the there is significant difference between the levels of the whole plot factor. Similarly, if the calculated value of f for subplot factor turns out to be significant, then we will say that there are significant differences among the levels of subplot factor.